right, so let's dive into some problems from chapter 10. First one is example 10.3. So I'm not going to read it. You can read it, but I'm going to pull out what it's telling me. Let me get my pen ready. All right, so it says a woman has an initial lung volume of 2.75 liters, which is filled with air at atmospheric pressure of 1.02 atmospheres. If she increases her lung volume to 3.25 liters without inhaling any additional air, what is the pressure in her lungs? All right, so the variables we're looking at are pressure and volume. So we go to our formulas. Pressure and volume is going to be Boyle's law. P1 V1 equals P2 V2. So let's plug in. P1 would be 1.02 atmospheres. V1 is 2.75 liters equals, we're looking for P2, and we're told that V1 is 3.25 liters. All right, so do your math. I'm going to multiply 1.02 times 2.75. Then I'm going to divide both sides by 3.25 liters. Liters cancels. 0.25 liters. So 0.863 atmospheres equals P2. All right, one way to check this is if pressure increases, my volume should decrease. Or if volume, in this case, I'm increasing my volume. So volume went up. So my pressure should go down. It did. It went down from 102 to 0.863 atmospheres. Okay, so that's pretty easy. Next one. It's example 10.3. I'll give you a second to read it. All right, it says a sample of gas has a volume of 2.8 liters at an unknown temperature. So volume 1 is 2.8 liters. T1 is unknown. When you submerge the sample in ice water at 0 degrees C, the volume decreases to 2.57 liters. What is the initial temperature in both Kelvin and degrees Celsius? All right, this example, we are looking at just volume and temperature. Oh, me, sorry. Oh, what did I do? What did I do? Can help. I always need help. So V1 over T1 equals V2 over T2. Remember that temperature must be in Kelvin or you will get the wrong answer. So since T1 is just 0, that's 273 K. Okay. and I'm looking for T1. So with this equation, the most common error I see is y'all not being able to solve for temperature because it's in the bottom. Okay, so let's go ahead, cross multiply, and get our T1 by itself. So I'm going to cross multiply both of my temperature terms. So it is V1 times T2 equals V2 times T1. I want T1 by itself. I'm going to divide both sides by V2. Okay, now all I have to do is simply plug in my numbers. So V1, 2.8 liters. T2 is 273K. V2 is 2.57 liters. Liters cancel, and I'll be left with Kelvin. So now I just do my multiplication and division. I get 297 for my T1. Okay, so that would be my initial temperature in Kelvin. So what would it be in degrees Celsius? I would simply subtract 273 because I didn't do any decimals. It would just be 24. Degrees Celsius. So again, let's look at this and make sure that it makes sense in terms of our volume and temperature relationship. They are directly proportional, so if one increases, the other should increase. One decreases, the other should decrease. All right, so I started at 208 liters. I just found my T1 to be 297. I decrease my volume. That would cause a decrease in temperature, so that makes sense. All right, on your slide, if you picked it up out of my office, I don't know where I got this problem, and so I couldn't, I didn't add it here. It says a sample of carbon dioxide occupies 0.3 liters at 10 degrees Celsius and 750 torr. What volume will the gas have at 30 degrees Celsius and 750 torr? All right, so in this example, you're given pressure, but you'll notice that pressure doesn't change. So we don't have to worry about including that in a calculation. So we're just back to volume and temperature. I don't know why I can't quit yawning. So 273 plus 10 would be 283 Kelvin. And 30 plus 273 be 303 Kelvin. So now we just plug them into our equation and we solve for V2. So again, it's V1 over T1 equals V2 over T2. I'm trying to find V2. So this time I'm just going to cross multiply these two to get my V2 by itself. So it'd be V1 times T2 over T1 equals V2. plug in your numbers. 0.3 liters. 303 Kelvin divided by 283 Kelvin. Kelvin cancels. Get V2 to be 0.321 liters. Right, so my temperature increased slightly from 10 degrees to 30 degrees. So I had a slight increase in volume, very slight, but at least it went up. So that tells me I probably did it correctly. All right. 10.0. All right, it says a male athlete in a kinesiology research study has a lung volume of 6.15 liters. So let's say volume 1.15 liters. At this volume, his lungs contain 0.254 moles of air. During exhalation, his lungs decrease, that V2 to 255 liters, 2.55 liters. How many moles does the athlete exhale? So this is Avogadro's law. Remember, in Avogadro's law, volume and number of moles are directly related. The equation is V1 over N1 equals V2 over N2. So just like with Charles' law, I'm going to cross multiply to get both of these ends off the bottom. So it's V1 times N2 equals V2 times N1. I want N2 by itself, so I'm going to divide both sides by V1. Okay, so there's my equation. Now let's just plug everything in. Oh, what am I doing? Still don't know what I'm doing. You'll notice that it helps if you write out V1, V2, so that when you go to plug it in, you can just look up and say, okay, this goes there, yada, 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 boom, bam, done. So now I'll multiply and divide. Okay, my moles decreased to 0.105. That makes sense since my volume decreased. So that should be correct. I don't have these worked out, so if I don't get the right answer and you are 100% certain that yours is the right answer, just let me know. I can't stop yawning. I don't know what it is. Okay. Next one. 10.5. All right, 10.5, we're getting into the ideal gas law now. It says, what is the volume of 655 grams of gaseous CH4? You'll notice that I didn't put my 4 as a subscript. And for whatever reason, when I put this degree sign, it leaves this huge gap. I'm not understanding, but whatever. At 25 degrees Celsius and 745 torr. So the reason I know that I'm not using one of the simple gas laws is I'm not comparing any changes. Okay, the pressure's not changing, temperature's not changing. I'm simply given several different properties of this gas and asked to find the missing one. Okay, so my equation PV equals nRT. I'm looking for volume, so I'm going to go ahead and divide both sides by P. Okay. All right, so I was given grams. I need moles, so we got to convert 655 grams of CH4 1 mole of CH4. Okay, so the molar mass would be 12.01